All right. So let's see if we can talk our way through 6.1, number 2. So we're just warming up, right? Stretching out. Okay, so I have an object stretches a string 1.2 inches in equilibrium. Okay. Find displacement for. I'm assuming they meant instead of string here. What do you think they probably meant?
Spring.
Yeah, I'm gonna assume they meant spring because they didn't teach me to solve string problems in here. Okay, so that's good. All right. So we've got a displacement of 1.2 inches in equilibrium, and we're supposed to find its displacement for t bigger than 0 if it's initially displaced 3 below equilibrium and given a downward velocity of 2 feet per second. Okay, so picture first. How are you guys imagining this thing oriented?
Up and down.
Yeah, probably vertically. So I have like a thing and then like a spring and then like a mass, something like this. Okay. And then we're initially displacing it, so it's going to be a little bit stretched. Like it hangs here and then it's going to be stretched out a little bit, right? So I'm thinking about that as like y of 0 is what?
1.2. Initial position.
Oh, okay. So I have this sort of other statement here, right? So there's two displacements given, right? One is 1.2 inches in equilibrium, and the other one is that it's displaced 3 inches initially. So one of those is going to be my initial value, and the other one's going to help me solve for the spring constant.
So we'll go with 3 for the initial.
Yeah, so I think the initial's 3. That does put your. So that puts kind of like, okay, so we're hanging here. This is equilibrium, right? You guys see that? And then this is now positive. When did that get decided?
We decided it
When?
just now.
Yeah, when Bridget said 3 instead of -3. So, Bridget, going forward, if this ends up wrong, it's probably my fault. But you can take secondary blame.
Okay. Deal.
And this is a little bit important just to think about, like, okay, so when you're making a mathematical model, you get some choices, right? In this case, we made a choice subconsciously, but it was still a choice that was made. And then we're given downward velocity, so that means that y prime at 0 is going to be something. What is that going to be?
+2.
Yeah, and I'm going to have a weirdness, right? This is, what are the units on my 2 here?
Feet per second.
And what are my units on my 3 here?
Inches.
Shit.
Oh, just multiply that 2 by 12.
Yeah, can we convert it?
Yeah, let's convert now before we regret it. So let's call that 24 inches per second. And I'm still going to regret all of this because this is the section of the book that I personally have the most trouble with because units are a nightmare. And I am bad at physics. So there we go. All right. So what's my kind of governing equation here that I need to lay my hands on?
The y double prime plus. I've just been using omega squared y, but it would be k over m or g over delta L.
Just shit, you know this stuff better than I do, Jacob. All right, let me supply my dumb idea here. I'm going to say it's my double prime plus ky plus by prime equals, yeah, and then I'm going to need to know about the external force here.
We don't have an external force for this one. Isn't it just 0? Yeah.
Let's see. So I think I do have an external force here.
What about our object stretching our spring? Is that an external force?
Well, that isn't that.
That's the part that in my mind implies that there's an external force. You guys see this? What do I think the external force is?
Mass and gravity.
Yeah, I think the external force here is gravity. So ultimately here, and this is really because I'm too dumb to remember physics equations, I tend to think about this whole thing as the sum of the forces as vectors is the mass times the acceleration.
Yeah.
This is like the only thing that I can be bothered to remember because it's not that hard. And then from this, I think I can build my kind of situation here. So I think I have on this kind of mass here, right? I'm seeing that I have a couple forces. I have a force kind of pulling down, that's gravity. I have a force trying to pull back up. What is the pull back up force here?
Spring.
Yeah, the spring itself. And then what else would there be? What's the other one here?
The drag or dampening.
Yeah, there might be some kind of friction in this system. Do they tell me anything about friction here?
No.
No?
I
Okay.
think the beginning of the section even says you don't have to worry about any of that.
I'm just going to assume there's no friction, but that's kind of a fair question to wonder about. So which of these three terms is which? Maybe let me replace this guy with this should be F external here. Oops.
Gravity is a my double prime term.
This guy?
Yeah.
I think that's my mass times my acceleration.
And it wouldn't be acceleration due to gravity.
I think that's going to be my external force.
Okay.
So yeah, so the mass times the acceleration overall, right, is the sum of the forces. So if I had to set this up, I'm going to set up, okay, so acceleration is going to be y double prime. I'm doing everything one-dimensionally, so I'm going to drop all these vector businesses. So I'm going to have ma, right, is going to equal, and then what are my forces? Well, I have my gravity force, and I have in the opposite direction my spring, right? So my gravity is going to be the mass times the gravity constant. I guess I should write that in green, shouldn't I?
I see.
And then I'm going to have in the opposite direction. I already decided that plus was down. Thank you. That makes my gravity positive. And now that makes the spring negative. It points in the opposite direction, right? And so that's going to be the spring constant times the displacement, which I'm going to call y. And then we're going to go back to the other side and we're going to think to ourselves, actually, no, we're going to get a number first. What is here?
In inches.
0.81.
Yeah, I'm going to rely on Jacob. In inches, what is the gravity constant?
384 inches per second squared.
Okay. And then one of the things that you can do that is frankly the way I do physics, I check to see if the units match. So on this left-hand side, I'm going to have a mass times an acceleration. An acceleration is going to be in inches per second squared. Cool. That at least is the right category. This thing, y is going to be in inches. And then I guess my spring constant is... Well, I guess I'll have to trust that the coefficient or that the units on that one work.
I think it would be some unit of force per inch.
Yeah, should be force per inch.
Yeah.
Because really, I should ultimately get a force out of it, right?
Yeah.
Okay, so let's see. Okay. What's my next plan? I have this A here. Can I replace that by something? What's acceleration here? How about what's position here? What's the variable representing how far we are?
Y.
Good.
Oh, are you trying to get that it's y double prime?
Yep.
Okay.
So my double prime should be 384 times m minus some spring constant times y. Okay, now this is the part where I'm a wee bit confused, right? Because like I should have a differential equation that I ought to be able to solve, yeah? But I seem to have like one too many numbers, one too many letters. And I also haven't used some information. So what haven't I used and what can I get rid of with it?
Well, you know why. Well, I guess, are we doing this at equilibrium?
I don't know, are we?
Okay. I assume we're doing this at t equals 0.
Okay, so is t equals 0, does that correspond to equilibrium?
For the, well, I mean, I guess that's how you interpret it, like how you want to set your coordinates and stuff. But
Well, but they told me my initial thing was I have to pull it down 3 inches and then give it a really friggin' big push, right? Down. So I'm like stretching this thing out a little bit and then hucking it downwards.
yeah,
But that doesn't feel like equilibrium to me.
no.
So this weirdness about equilibrium lets you get rid of one of these variables here. So which variable might I be able to get rid of here out of these guys? Do I know how much the mass is? No. Do I know how stiff the spring is? Only kind of relatively, in that they tell me that if you just set it on there, right, it stretches down in 1.2 inches. You guys see that?
Mhm.
So if I just set it on there, is it accelerating?
Briefly, and then it stops.
Okay, so if I were to just, and this is, I realize this is physically impossible, but it can be close enough that you won't notice. If I very carefully adjust it, right, I think about putting my hand underneath it, moving my hand down real slow until it lifts off my hand. Is it accelerating at that moment? Like, as it just chills there, dangling from the spring, is it accelerating? No, right? So at equilibrium, the acceleration is 0, right? So at equilibrium, the left-hand side of this equation must match the right-hand side. Or alternatively, this stuff comes out to 0, right? So 384m minus k times something equals 0. What's the something here?
The displacement from the natural equilibrium point.
Yeah, so what's the
Would be
1.2
inches.
goes here? You guys see that? So then I can solve for k. So we add 1.2k to the other side, and then divide by 1.2. You get k is whatever 384 over 1.2m. You guys all with me on that? Okay, what am I going to do with that?
Plug it in for k.
I really wish you had sung that. Can you sing it to the tune of Glade?
I don't know what that is.
You guys are probably too young for this shit now.
For what, dude?
There was an old commercial on a thing called television, which is like when your phone is in front of your face, but it sits in the corner of the room, and it's beamed from space. No, that's not actually true. Forget it. You guys know this. It was like commercials. Wait, those happen on YouTube now. This is a terrible time to live in. All right. Put this in here. So we're going to end up with my double prime, and I'm going to bring this thing to the other side. So I'm going to have plus 384 over 1.2 m. What have I lost here? What's that guy?
Your y?
Yeah, that guy's just k, so there should also be a y, and this should equal 384m. You guys with me? Okay, now what?
Divide by m.
Yeah, for sure. Whack a mass off of that thing. So you're going to get y double prime plus 384 over 1.2y is 384. Okay, now what? Kind of hurts my head what's happened here. So I started with some physics nonsense, right? And we kind of massaged our way out of physics nonsense, and now I have here a differential equation, right? What kind of differential equation is this?
Second order linear.
Second order linear. Good.
Non-homogeneous ODE.
One more.
One constant. Is that what
Yeah, well, constant coefficient anyway, right? The coefficients being 1, 0, and 384 over 1.2. You guys with me on that? Okay, so now I have to apply this technique for Twachtlenhodes, or however the hell you say this word. So I think the technique for that is that I have to solve the homogeneous version first, right?
What?
Okay, so I'm going to take this over here. And solve this. I guess I put H's on these for homogeneous. Then what? What do you get out of this?
Should we go Pythagorean theorem route? Get some R's.
Good. Okay, so
I'm not a factor
substitute.
that.
What's that?
I'm not a factor that.
Yeah, so you get quadratic formula. Okay, so I got this, right? After I did my characteristic equation, so I kind of guessed why h is e to the rt here. It's not going to end up being an e to the rt, it's going to end up being cosine and sine, right? How do I know it's going to be cosine and sine without like fiddling with this too much?
Your discriminant's gonna be negative.
Yeah, it's an undamped spring, right? It's going to bounce. The only options are that it's going to bounce or that it's not going to move. And I moved it out of equilibrium, so it's going to bounce. All right, so we're going to get R is plus or minus this thing, 384 over 1.2 under a square root, under a square root with an I attached to it. Pretty believe me there? Subtract square root both sides, you get this. It's purely imaginary. How did I know it's going to be purely imaginary? How could you have guessed it's going to be pure bouncing?
You have no B term.
Good. Yeah, there's no friction. Right? So it's not going to bounce less and less over time because the energy is not going anywhere. Okay, so I got this. So what does that mean my solution looks like? YH is what?
C1, and I believe that's a cosine, and I believe that square root comes out to 8 root 5.
Really?
Yeah.
Well, the 1.2 divides evenly into 384.
Yeah, it does actually.
Oh, sick. All right, so what did I get? 8.5?
8 root 5.
Oh, 8 root 5. Okay, so I got 8 root 5
X.
times,
X.
yeah, X or Y or
Or
no.
Y, T, whatever, it doesn't
T.
matter.
Not Y, importantly. Something other than
Oh
Y.
yeah, other than Y, yeah.
Yeah, variable of your choice, not Y. Plus C2 sine of same. Pretty good with that?
Mm-hmm.
Okay. So that was the homogeneous part. Now, how do I solve for the non-homogeneous part?
Don't you need to differentiate y homogeneous twice and plug it in? Plug y homogeneous and y double prime homogeneous back in?
Remember, I know that if I differentiate those things and plug them back in, I know they're going to zero out, right? I'm trying to find a particular solution, which means I want to look at the right-hand side. What kind of thing is the right-hand side?
Constant.
Good, it's constant. So what kind of function can you differentiate a couple times, multiply by some constants, maybe add back to itself, and still end up with a constant?
Is that where we're going? E to the something.
Close. If you differentiate e to the somethings and add them together, right, you're going to end up with e to the somethings.
So it's just a constant.
Yeah, I want just a constant. Now, I'm worried that a constant might go away if it might be one of the homogeneous solutions. Is just a constant one of the homogeneous solutions?
No, because you won't end up with 0.
Good. So if I'm not worried about it, my y particular guess is going to be A. You guys with me on that? That felt a little weird, right? What I'm really doing is I'm looking at AY double prime plus BY prime plus CY equals a number, right? And I'm thinking to myself, okay, this is a degree 0 polynomial, so I'm going to guess a degree 0 polynomial. You guys with me on that? If I had 384x here, I'd be guessing ax plus b. Because if you differentiate polynomials and add them together, you get polynomials back, right?
Can I just say real quick? I don't think you need a particular solution for this one. I think it was meant to be a homogeneous equation.
Maybe.
In the book, it's written as a homogeneous equation, like in the back.
It
There's
doesn't
no-
just. It should have plus a constant on the end.
I don't think it does.
Oh, that's a mistake on their part.
Is it 6, 1?
Yeah, that feels like a mistake on their part.
I don't think it is. I don't know. I at least
Certainly that's up to, yeah, that's kind of up to interpretation, right? So if I had wanted that, like if I was writing this question and I wanted that interpretation, I would have said an object stretches a spring 1.2 inches in equilibrium under the force of gravity. And then said, find its displacement, blah, 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 assuming that gravity is turned off. I don't think it's fair to tell you that it stretches a spring under an ambient gravitational field without then assuming that the gravity's on for good.
well I'm just like the proof they provide in the book for why it's like that basically just gets rid of that entirely. Like gets rid of the external force term.
Yeah, I mean, it should end up just being a midline shift. Right, so if I think about gravity being on, it's just going to add that to the spring to begin with. So it should just shift the midline down. But this is going to demonstrate why it shifts that midline. Let me hammer through this, and then we'll pull up the solution and compare and contrast.
Okay.
All right, so I want to guess y prime is A. This is going to be relatively straightforward, and then I'm going to take yp double prime, which is going to be 0, right? Then I'm going to plug this in here. So I'm going to get 384 over 1.2 is, times A is equal to 384. I'm going to solve here and figure out pretty quickly that A is 1.2. And so then I'm going to say, all right, so my total solution then, my y as a function of t, is C1 cosine of 8 root 5t plus C2 sine of 8 root 5t plus 1.2. Okay, and then I'm going to say, all right, so then it's displaced 3 inches below equilibrium to start with. So I'm going to take my initial conditions from up here, and I'm just going to bring those down so we can talk about them. All right, so I went and got my initial conditions, right? Now, I want to plug these in and solve for what? What should I be solving for here?
C1 and C2.
Good. I need to solve for C1 and C2. So if I think, all right, if I plug 0 in here, that should be 3 on the one hand. And on the other side, that's going to be C1. What's cosine at 0?
1.
Good. and sine at 0.
0.
And I have my 1.2 here. So I'm going to subtract to the other side and get what? 1.8 is C1. Okay, so I can plug that in. So can grab our y here. Oops, why'd you end up over there? And we can drop our C1 and put in a 1.8. And then we can differentiate this whole thing. So I need y prime of t is going to be 1.8 times 8 root 5. Cosine turns into which?
Sine.
And I'm going to have an 8 root 5t. That gets a minus sign, doesn't it?
Cosine down to sine. It's
Derivative of cosine is minus sign. I think. Pretty sure. And then I'm going to end up with 8 root 5 c2 times cosine of 8 root 5t. And then I'm going to have plus 0, right? So now I'm going to plug in y prime at 0. So I'm going to get 24 is going to be on the other side. Let's see, the sine piece zeroes out. And I'm going to have 8 root 5 c2. So c2 is going to be, what, 3 over the square root of 5? And so we'll finally plug that in. And we'll get, oops, keep your S's. Okay, so we'll get this final thing. Okay, now let's think about what we have going on here. So this whole business here is our kind of oscillator, right? I don't know how to spell oscillator. So that's the kind of bouncy piece, yeah? Okay. What is this other plus 1.2 thing?
I keep having to remember that you switched your axes, so that would be the
Everything is minus signs on yours?
yeah.
Yeah.
Because I plugged it in, I did -3 minus 1.8. That doesn't make sense. That's not what you have.
So ultimately what I have here is this oscillating bit, right? And then this 1.2, this guy, that's a midline shift. And so if I had been a little bit more clever back at the beginning of this, like if I had remembered how to do physics, I could have said, okay, so look, if it shifts it by 1.2 inches in equilibrium, that does two things. It lets me figure out the spring constant, and if I was a little bit smarter, instead of declaring 0 to be its unweighted equilibrium point, like where the spring would sit with no mass on it, I could have let this, where the spring would sit with the mass on it, be the 0 value. So I could have let it, just calculated the spring constant and then gotten this 1.2 right out of my system here. So I could have set this thing up as a homogeneous equation with a 1.8 as my initial condition instead of this 3. That make any sense?
So The way I've been setting it up and the way the book showed me is that you set it up as y double prime plus g over the distance in equilibrium
Mm-hmm.
times y equals 0.
Sure.
Then
Yeah,
that's
it's
what I was
really a
talking
question about that initial value. So if you set it up that way, the difference, the distinction, is going to be that here I have 3. And if you set it up in this other way, you'll have here this is 1.8. Does that make any sense?
Wait, but isn't that 3 inches below the 1.2 inches?
Oh, I don't know. That's up to interpretation. That's the difference in their
That-
interpretations here.
That's what I was thinking, is if it's at 1.2 inches in equilibrium from its natural equilibrium, then 3 inches below that is where it starts.
I see. Okay, that's probably that's probably a reasonable interpretation.
But that might also be why I'm getting all my answers wrong. Because I feel like I'm doing the setup right and all the math right, but I'm not getting the same answers in the book, nor is this the same answers in the book either. But
Okay, let's look at what they got just for kicks. Let's see. So I'm looking for chapter 6 here. Whoa, whoops. Cannot be selected in the table of contents when you hit page down. Let's see, and we are looking at 6.1 number 2. Oh, which has over quarters?
yeah, that's what I was confused by, because it's like completely different besides our 8 root 5.
Yeah, let's drop this side by side and see where we're. Over a quarter.
And this is the same exact issue I was having with problem 13. Is I have all my setup right and stuff. It's just my coefficients are different.
Yeah, I'm wondering if I'm having. So let's see. So if I was wrong about my reading comprehension, right? It's possible. Then my initial condition should have still been y of 3 is 0. If my external forces are 0, that just means that I'm not having this 1.2 in there. Okay, so I'd have C1 is then 3, not a quarter. Oh, but 3 inches is a quarter foot.
Oh my god.
This is the
wow.
this is the welcome to why Joe hates physics.
Yeah.
Because if you don't write down the units, which mathematicians tend not to, then it's really quite easy to get all jacked up. So yeah, so I interpreted this as it displaces another 3 inches below this 1.2 inch displacement, and that's not what they.
You mean below the 0?
Sorry, I put my 0 at the unstretched spring, and then read both of these as like, okay, so if you put the mass on it, then it displaces down 1.2 inches, and then we're going to displace it another 3 inches below that, and they're reading this a little differently. Sorry, I'm assuming that they're displacing 3 inches below that kind of unweighted spring to start, and they're assuming they're displacing it 3 inches below where it's kind of weighted equilibrium.
Mm-hmm.
I think that's a reasonable place to have a disagreement. They're probably more right than I am. The reason I think they're probably more right than I am is that when I read this, I looked at this in and somehow I read below.
Oh, okay.
So I read these both as below, which made me think that okay, so there's a 1.8 inch difference between these two. They're saying just look, dude, the spring stretches this much. Now go. So that's maybe a reasonable place to disagree. But I think they're more correct.
Okay, I think that's why I had 13 wrong too. Is just the units.
That's that's gonna be the source of most error, right? Is we had this thing between inches and feet, and we switched to inches, and they said, of course, dude, I don't know what the gravitational constant is in inches. I'm just gonna write it. I'm gonna move everything to feet and write it down there. So their y's are feet of displacement, and our y's are inches of displacement. Pretty good with this? Okay, cool. That took forever.